everyone. I'm here with Cobra. I'm actually in Cobra's office right now because I think this 3D printing stuff is a big deal. I'll let you guys introduce yourselves and tell me what you guys all really do. Obviously, TO forever.
Yeah, it's been a long time, I guess, 30-some years. Tom Olsavsky, TO for short, Vice President of R&D on the club side. So we're excited to have Mark here. I love talking with him all the time.
Cool. Mike Yagley, VP of Innovation, and our team is responsible for delivering all the crazy ass stuff to Tom so he can turn it into a.
So he gets some of the crazy ideas and
yes.
You guys can get it done.
Oh yeah,
cool.
yes.
Yeah. And I'm Ryan Roach, also on the innovation team, Director of Innovation, and I work under Mike Yagley and been involved in a lot of the additive stuff that we're doing to date.
Right, and this was all 3D printing stuff,
Yeah,
right?
3D printing.
So it's you they came to when they said, you got to get this done, right?
Well, yeah, or we finally pushed it up enough. Hey, do this, right? And it's done.
So, but basically, I've been looking at the 3D printed irons that just came out. I think it's really cool. There's a lot of stuff going on with what you can do that you can't do with forging or casting, which I find is really interesting, and obviously the potential for what we can do with other things. Obviously, it's expensive, which is kind of why it hasn't been mainstream already. But that price is coming down over time, right? And the advantage of being able to 3D print anything you want and make minor adjustments and stuff, I just think is really cool. On top of that, we tested it on the robot, and we do a pretty substantial test, but not we're going to do more at the end of the year. But it actually was the closest to the pin all around on the spots right around the center of any club we tested. So that really got me excited. This technology really is going somewhere. So just kind of filling in a story of how you guys came to market first. You're not the biggest company out there. You're not a small company either, but I think it's kind of a cool story for the industry that you guys came to market first, and we've got 3D printed clubs that are on the market for consumers. How long have you been doing it for tour players, and who's been in charge of that? You've obviously done
Roachie's been doing most of the work.
Yeah, so
he has.
We've been looking at the 3D printing additive. I kind of interchange those words, but we'll call it 3D printing. We've been looking at that for a long time. I'd say since mid-2000s, mid-2010s, we've been doing it in our innovation process, right? In metal, to make prototypes for tour, make prototypes just to speed our process up, because in innovation, we might only need 5 parts to test.
Right.
So you make a whole tool to make those, and it takes money and time to do that, or you can now transition to just printing them, test them quickly, test 5 different versions at the same time. Really speeds up our process and lets us innovate faster. So we've been doing it since mid-2010s, I'd say.
Now, you guys had putters on the market for a while too, so it's not new to you guys. You kind of being the leader in this.
Yeah, well, we explored, I would say, all kinds of 3D printing processes. We were looking, no stone unturned type of thing. We were looking at everything because we're pretty excited about the potential of what it can do. And when we found that, certain technologies are ready perhaps to bring something to market, we'll jump on that opportunity.
And it sounds like you got the message from above that this is going to market faster than you guys were planning. You got to fill me in on that story.
Yeah, it was one of my favorite moments in my career.
Right.
So, as Ryan said, we've been doing 3D printing metal products for tour players. I think we had probably close to 50 at this point, and like north of 15 of those had been put in play by tour players.
Right.
But they're expensive.
Yep.
I mean, the cost of making those heads just a few years ago might have been like $500 for an iron head. Right.
But you remember, before that, you were just milling them out of a block, which isn't cheap either, right?
Yeah.
And time consuming. So,
correct.
Kind of close.
But there are things you can do with 3D printing that you can't do with casting or forging or machining, right?
Mm-hmm.
So we're doing this, and Ryan had scoured the earth for suppliers that could supply a 3D printed iron at a reasonable cost. When I say reasonable, something that we believe that consumers would pay for.
Right.
And he found them. And we were at a point where we had to make a decision, like, we really going to do this or not? And I'm going to bag on you for just a second, because we had TO and Hose. People know Jose Miraflor, right? We had Yasu Oba, who's the head of our operations group, Doug Roberts, head of design. I had him in a room upstairs called Pebble Beach. And they're like, I don't know if we could really commercialize this. Like, it's going to be too expensive. It's going to be too hard. I said, hold on for just a minute. I went down the hallway and I grabbed Dan Ladd, who's the president. I said, Dan, I need you for just a minute, okay? And he comes into the room and I said, tell him what we're going to do. And he said, we're going to commercialize this. We're doing this. And that's all he said. He kind of walked out.
And this is last year.
Yeah, this is last year.
Right.
This is January of 2023. Okay. And Dan said, we're going to do it this year. And I walked downstairs to Ryan and team and I said, Dan says we're doing it this year. And then of course we all turned white as a sheet, like, because it normally takes 2 years from when we say we're going to do something to when it actually ends up at retail.
Right.
Okay.
Well, we've got a year of just development, right? And then
and we need a
make
couple
it
years
just
prior.
ready.
We need a couple years prior to that to invent the technology.
Right.
So you're looking at like 3 years between, okay, we're going to do something to ends up at retail.
Right.
Now we had a head start because Ryan's team was doing a lot of work on this, okay? But to compress it into 1 year was quite a challenge. And the code name prior to, the code name became Apollo. The code name prior was?
So it was Barker.
Right.
As in Bob Barker. Because in our team, we said the price is finally right for us to do this. We can do this. So that was like the convergence moment where we're like, you know, get goosebumps thinking about it. Like,
You
hey,
can sell
we can do
$2,000
this
a piece iron.
Yeah, hey, this might make sense. And so then that just spurred us on even more, you know, to just get it to the point where the rest of the business would be like, kind of ready to go with it, I suppose. Ready to be convinced that, yeah, we can do this.
So I'm thinking if we walk around the building now and say the code name is Barker and we say Bob Barker, the rest of the company may not take us real seriously, right?
Yeah.
Oh boy. So I said, I was reminded of JFK at Rice University in 1962 when he said, we choose to go to the moon, not because it's easy, because it's hard, right? I'm like, we're changing the code name. So we changed it to Apollo right there, right? Because it just was a stronger statement. And we didn't quite meet the 1 year requirement.
You got close.
We got close. And I tell you, from what it took to make that happen, I'm so proud of Ryan and the team. Yeah. And Tom's team threw in a lot of really good ideas because you see it. It's a really sexy club.
Yeah, it really does look cool.
So, I mean,
it was
teams worked great together.
Really hard to get it done. Super accelerated process. Yeah.
Well, you're first to market with it. I mean, you know, if you look back on the years of, you know, innovation in golf, you got, you know, when TaylorMade came out with a metal wood, I think that was a big deal. When Galloway came out with a titanium driver, that was a big deal and change. I think this is a pretty big deal and change. And obviously this technology is going to get cheaper over time. But, you know, give me some ideas of what's the, I mean, I kind of have some ideas myself on what the advantages are for, you know, 3D printing versus casting and forging. But, you know, fill me in a little bit on what the difference is and on what's the advantage of 3D printing versus casting and forging.
So I'll start. I alluded a minute ago, it's like forging's been around for hundreds of years, if not thousands, right? So in golf, it's been around for hundreds of years. And we've been casting for, you know, decades now.
Right.
And there are things you can do with those two products that are really good. Forged is, it's solid, it feels good, it gives you decent mass properties for a really, really good golfer. Okay.
Right.
Then you cast things and you can get more perimeter weighting. You do undercuts. So now you can make a club that is good for, we'll say, the average player, 15, 20 handicapper. It's more forgiving.
Right.
Well, there's things you can't do with those two technologies that you can with 3D printing.
Right.
You can do things on the inside that you can't forge, you can't cast, you can't machine it, but you can make that product that's been 3D printed feel like a blade, but perform.
Which it does, by the way. Yeah.
Thank you. Yeah, but perform like a Game of Through iron. Okay.
Yeah.
And so it was no easy trick to do that. Ryan can share like how we actually created the inside of that head.
Yeah. And one thing also that I will pile on Mike with is the ability to iterate quickly because there's no tooling.
Right.
Right. So, you know, we're doing this for the first time. You can imagine there's some ups and downs and learning moments, but we can, you know, fail fast and continue, right? Continue on and fail faster than we ever could before, really, because we can just iterate it, right? So I just wanted to, you know, that's another huge advantage.
It really is.
That we were able to leverage to get this to market as fast as we did.
Well, if I understand it correctly, right, so forging, just for our audience and stuff, obviously pretty intelligent audience for our group, but, you know, is actually slamming it together, right?
Yeah.
Compacting the metal, which makes it, you know, gets the grains going the right direction, so it makes it stronger than, you know, just pouring a liquid. Casting, you know, the advantage of that obviously is feel, but you can't do anything in the middle, you can't put anything inside because it's being compressed. Casting, obviously, you can do cavity backs and a bunch of things that you can do, undercut cavities and stuff like that. And a lot of the irons now are actually two-piece, right? So there's either a forged or cast face, and putting them together so you can do, you know, hollow clubs, which you've seen a lot in the last couple of years, which is cool. But, you know, from my understanding, we actually do use a 3D printer, just, you know, plastic 3D printer, and we do it for, you know, often live parts and machines and stuff. And what's really cool about it is that you can't do with forging or casting is you can change the density of the material as you go, right? And what that means basically is, for our audience is, you can have it 100% material, right? So it's solid. You can do 50% material. You can put some kind of, spacing in between, basically. You can do 25% or any percentage for the most part, right? Until the structure gets, 10%, obviously, not
gotta have
compression stuff. And what that is it's basically a lattice is what they call it, right? So a lattice is basically, and if you guys correct me because I'm not the expert on this, a lattice is how, basically a structure underneath that supports it. So you think about a bridge that's got, triangles and stuff that supports it and stuff. And some shapes are stronger than others for certain reasons. And there's probably a bunch of different ways you can do that. You can visibly see it in the back of your iron. We did this really complex lattice, which probably weighs, 5% of whatever the total material would be. But being able to change the density in all the parts is pretty cool. Now, what I don't understand, which I'm interested in, is how do you get the tungsten in there? You actually stop halfway through the process, put the tungsten in, and then turn over the top, or how does that work? Because you got 100 grams of tungsten in these irons, varying obviously depending on the club. But that gives you the ability to really, now you're not only being able to vary the material you've got for different densities, but now you're adding another material with a totally different density that you can put. How does that all work?
Yeah, so we will get to the point someday where you're going to be able to print,
Different
tungsten
materials.
here, steel here. I mean, that technology does exist. In this case, in the development process, we actually 3D printed tungsten parts to put in there, but we don't print them at the same time as the body, right? So the body's printed, and then we use a special process that gets the tungsten in, but the tungsten is put in after the body is printed. And we 3D print the caps that go over the top.
Oh, gotcha. Right. Okay.
Right.
Yeah.
And then we.
That's kind of what I figured. But
So.
So you can actually
you
stop
3D
3D
print the tungsten
printing and then
pieces.
put the stuff in and then 3D print over the rest of it.
Well, you actually
not exactly
traditional stuff welding. Polishing.
Yeah. So we do attach those caps. The body's 3D printed and the caps are 3D printed and the tungsten pieces are placed in, but that's after the part's off of the printer, so to speak. So imagine you have a body and a couple caps printed. Okay, we got the tungsten and we assemble them together.
Put them all together.
Yeah. So
Ryan said special. We'd also say proprietary. We're not going to go super deep on how we install it.
I'm saying that's part of the trick, right?
It's proprietary.
And Mark, you mentioned a couple things with the lattice structure, right? So it's really critical, as you said, you can reduce basically the effective density of what's on the inside by latticing the inside. And we've literally removed 100 grams of weight from the inside of that head. So we can put 100 grams of tungsten, depending upon the player numbers on the bottom of the club, so around 100 grams into that club, which is a huge deal for low and wide from a mass property standpoint, which means low CG and high MOI. But back to the lattice thing, and you mentioned feels like a blade. So it looks like a blade, feels like a blade. The big deal is you've got a lattice structure that goes from the back of the face to the inside of the back of the head. So you look at it and it looks solid, it feels solid, it has the vibration characteristics, which means the sound and the feel of a solid club, but it's not. And it's because that lattice does touch basically everything on the inside, most critically back of the face to the.
So everything's basically connected together.
It's connected,
That makes it more solid.
Yes, that's.
Then even shoot foam or something on the inside, which is never physically attached.
We don't need to. We don't. I mean, it's so rigid, and that's why forged clubs feel so good. The vibration frequency is so high that you're probably hearing mostly ball, but some of the club, and this one behaves just like a forged club. That's part of the secret sauce also.
So what material is this thing made out of? I mean, was it stainless steel, carbon steel? You're plating it. I haven't really looked into that at all.
Stainless steel.
Yeah. So stainless steel. And a particular type of stainless?
316L. 316 is what we're using in this iteration. It's a good proxy with the same kind of alloys that we forge clubs with in terms of hardness and kind of strength.
Yeah, I noticed because we adjusted them, and I was a little nervous to do that, to be honest. Because
I think people will be, but no, you can bend those.
Yeah, no, they bend like a forge club. I mean, they were really easy to bend. I mean, I'm assuming the hosel is pretty solid, right? Because of thin walls and stuff.
Yeah, there's some stuff in there.
Yeah, but you could make that even lighter, right? Just a little bit.
Okay.
Yep.
Wink, wink, nudge, nudge. Right. So you're touching on one thing also, like you were literally afraid to bend it, and I get that.
Well, the only reason being is because they're $3,000 a set. If I break a 7-iron, I'm basically $3,000 on it.
Yes, I get it. I totally get that. But then we've seen some comments and heard comments, people talking about how, oh, it's 3D printed, it's going to have to be, it'll be brittle, right?
Oh, it's not brittle. I can tell
It's
you that.
not. I mean, it is dependent on the material you're
Right.
printing and the process of 3D printing. The one we use, DMLS, is direct metal laser sintering. The mechanical properties of the material itself are above that of casting and approaching that of forging.
So it's somewhere between the two.
Yes.
It's how strong the material is, basically,
Yes.
and
So-
how malleable. Right?
Exactly. So people should have no fear of hitting the club, right? Using it for a lifetime, and bending it if they have to. It'll do all of those things. Yeah, it behaves a lot like a forged club.
Yeah, one of the things though, the last couple of years is we know how important fitting is and bending is. So everything we're designing now for
Yeah.
the mainstream is got to be bendable. It's a
Yeah.
pretty strong requirement.
Yeah. When we sit in this room, we like almost rhetorically ask the question, does it have to be bendable? And of course the answer is yes, it has to be.
Right. Yeah.
Yeah.
I mean, it doesn't need to be, you don't need gloves that bend a ton, obviously, but we definitely need 2 degrees in every direction.
Yes.
Kind of as a minimum.
Right.
Right.
Mhm.
I mean, if you got higher than that, as far as more upright or flat, I mean, that's a small percent of it. I mean, that's 98% of the population
sure.
is probably within that
Yes.
2 degree window somewhere. So that's not an issue.
The other cool thing about it is anything you can design in a CAD file with the analysis that guys use to analyze and make the lattice,
Right.
anything you could design, they can print. So
Right.
that's pretty cool.
So what's next? You know, where's this all going?
Did you sign the paperwork?
I'm going to give you an NDA after this.
Okay.
Yeah. Yes. Because we do want to ask you a lot of questions off camera. too.
Okay, that's fine.
Oh, yeah. Yeah.
All right, but you're obviously be coming out with these. You think this is the beginning, and you're going to do more of these and customized ones and all kinds of things down the road. I mean, I certainly see it that way. I mean, I see this as kind of the future of high-end part of clubs anyway. I mean, obviously, it's still going to be a while before their cost gets close enough to casting a club for the general market. But there's obviously a market for $400 or $500 irons. We've seen that in the past recently, and
Mhm.
if the price is no object, there's some pretty cool stuff you can
To your
do.
point, people are paying $600+ for a driver.
Right.
One club.
Yep.
So,
And
The roadmap you just laid out is
pretty close.
one we've been talking about. Yeah,
Okay.
we'll leave it at that. Yeah.
All right.
But you can also look at what else we've done, like what Ryan and team has done, and you can go, okay, I get it. People are paying attention. We've taken Ricky's preferred wedge, which Ben Showman ground by
Right.
hand,
Yep.
right? And Ben has a hard time duplicating that at times.
I've done a lot of grinding, and it's
Exactly.
hard.
It's
I mean,
hard to
I don't
do.
care how good you are at it,
Yep.
it's very easy to hit the wheel a little hard.
Yes, and so this one's public knowledge, right?
Right.
We brought that wedge in, we scanned it.
Right.
Ryan and team catted it up, had it printed, and Ricky hits it a couple times, goes, yep, that's it. Gary Woodland hits it and goes, yep, I'll take one of those. Duffner says, I've got a special grind. Done that for him.
Right.
So there's a lot of possibilities in this world.
Yeah, especially
Yeah.
for wedges, I can see that because TaylorMade came out years ago with a face you could change, which made some sense to me because
Yes.
that's one part that wears out, right?
Right.
The rest of it,
Mhm.
once you get it the right grind and everything, you like it. Downside to that, obviously, is 2 pieces, doesn't feel as good, and there's some it's expensive. But to be able to, we actually looked into some machines to basically just scan the bottom, which is what you're doing,
Right.
and to be able to grind that, the machine. It's just for as much as we do, it's just not. It doesn't make sense. But certainly makes sense for tour players, especially the grind is so critical for them.
Yeah.
The bounce and angles and everything.
And someday they may not be saying grind. I might say it's my print.
Yeah, exactly, right.
That's a good point.
Yeah.
Yeah.
But literally in that case, you can, whatever Ricky likes, you could basically, have out there and put him a new one, whatever he wears it out, right? Exactly the same.
Yeah.
Yeah, so like wedges and putters, right? We've made the putter already,
Right.
and that was the first real exploration. That was a different process. So like I said, Roachy's been scouring every process. So we're trying to use the best process for each product. And we've done a 3D printed medallion system in nylon. The putters are nylon. So a ton of work that Roachy's done to really help us in a lot of different products, and we see lots of opportunity coming.
Well, you've been doing putters for a while now, right?
Well, we launched it, it was,
that's really helped
in
your
2020,
learning curve,
we
right?
launched, used HP's metal jet process to launch a steel putter,
Right.
right? And that was kind of our first commercial foray into stuff made with metal. And that process is a little different than the process we're using here. So there's advantages to that process from potentially for scaling it into a larger amount of parts.
Right.
But we used the DMLS process and the limited iron because of the way that we designed it. It would be hard to get the powder out of the design if we used the HP's process, because it's printing layer by layer, and there's an internal chamber with lattice in it, and you have to get the powder out, right? So
Gotcha.
in the DMLS process, that part is pretty much, it's hard and solid. It's hard and ready to hit right when it's printed. In HP's process, you do a sintering process afterwards. You print it at a larger scale, and then you put it in a sintering furnace, and it sinters down to your final shape. So there's the main differences between those two processes. So in the case of the limited iron, because of the design, we needed to use the DMLS process.
And that you don't that once it's printed, it's ready to go.
Yeah.
You don't have to reheat it basically and cook it down.
Not necessarily. You
Don't worry
can
about
heat
the
treat these,
shredded
but
and
you
all
know,
that.
it's kind of depends on what kind of specification you're looking for in the metal after.
Oh, I was impressed by the finish and everything. How it looks.
Yeah, so we plated
Awesome.
it. So it is
Right.
plated. Even though it's stainless, it is plated. It's not going to rust, but we decided to plate it because of the aesthetic and the kind of the family of irons it's in. Pretty much all of those are plated, I would say.
Right. Well, but that's the durability more than anything. Right?
Yeah, so you get bag chatter and stuff like that. It
Yeah,
helps
bang
with that.
together and stuff. Yeah.
Mhm.
So it's chrome plated.
Yeah.
Okay. That's pretty cool. There's definitely a lot you can do with that stuff.
It's exciting.
Yeah.
It's-
That's a
And
great word for it.
what about
I'm really excited.
woods and stuff? I mean, I've heard obviously you can 3D print titanium now and some other stuff. So you guys using that in R&D purposes at this
Yes.
point too?
It's very similar to the conversation we had about, okay, 5 years ago, could have done this with an iron. I'd say 5 years from now,
We've been
maybe
doing it-
titanium,
Right.
right? But right now, it's really expensive.
Yeah. I've heard some companies doing that. Obviously, they
Yeah.
customize faces and stuff to,
Yes.
for different players that want to see certain things. Obviously, tour players are a whole different deal than the average golfer. They're a lot
Yeah.
better. But they can notice all those differences. So it's kind of more in that realm. But just think it's cool that we can play around with those things and change them. I mean, I can see you kind of, looking kind of way forward, right? As this gets less expensive and stuff. I mean, there's no reason we couldn't have at some point in time, I like a little more offset in my long irons or whatever, or more bounce or stronger lofts that you could actually, go in and build a custom set to whatever you wanted, really. It's expensive, but I mean, that's not crazy, sometime in the future.
Yeah. Is this the point where we bite our lip and don't say anything?
Yeah, I'm thinking, okay.
Wink.
That's enough of a wink. Yeah. I mean,
But the good thing is
Great
that's
idea,
what I see.
Mark.
We are-
That's really-
Yeah, I'm sure I'm not the first one to thought of that. By the way.
Well, and the good thing is we're doing a bunch of stuff. That's when Mike said 50 tour projects.
Yep.
We've made pretty much every kind of club.
Yeah.
For them.
Right.
So we're learning, we're exploring these different processes. We're trying to understand the business viability of how big it can be,
Right.
how fast the cost can come down, how many capacity.
Yeah, that's the big thing on
All of
cost, right? I mean, obviously it's expensive now. You obviously get it down to a price where you can sell them for 400 and what is it, 28.57 or something like that. But every time that comes down,
Rain Man. That was awesome.
Trying to do the math in my head. I'm not exactly right, by the way. But as it gets cheaper and cheaper, you can get those things down to
Yes.
$250 a club. That's kind of in the ballpark of clubs are $200 a piece
Right.
now, right?
Mhm.
And that's not crazy.
And there's a
Um,
big push in the 3D printing world to do that.
Oh, absolutely.
If people are paying attention, they're like, and if you're nerdy, like you're going into the publications on 3D printing and
Right.
looking at what companies are saying, they appreciate that if they really, really want to compete, they need to get the cost of printing metal down to that of either casting or forging, like to truly compete
Right.
at that level. And they've come a long way in just a few years. And
Yeah, just out of curiosity. So if this club is, it's called $400, make it easy.
Yeah.
Now, 5 years ago or 2 years ago, that would have cost double or triple that, right?
Oh, easily. We did the math. I did it a couple weeks ago, and I think this set would have cost about $12,000 for us to get a reasonable margin, for you to get a
Right.
reasonable margin, right?
And that was just a year,
That
2
was just
years ago.
that was just a few years ago.
Right.
Yes.
Well, I kind of tell the story because, when I had hot sticks when we first started out, one of the first ones to use plasma TVs.
Mhm.
And these 40-inch TVs we bought like 40 of them, right? And it was, I don't know, it was like 100 and something grand. And they were like $6,000 a piece. And they had touchscreens on them, which were just, really archaic. Now you can buy that TV for $200. So it's 10 times better.
And it's
So, I mean,
better.
obviously, that kind of technology, and this seems to be like a technology that's going to go the same way.
That's our favorite analogy to tell, right? For
Yeah.
people to go, oh, that's what's happening.
Right.
Yes.
I mean, your phone is more computer power than your computer did 10 years ago.
Yes.
By 10 times. So, we definitely head in that direction. So, I mean, this just seems like this is a natural use of that technology as it gets cheaper and cheaper, that you have more and more clubs. I mean, certainly wedges make a lot of sense to me, to be able to have, all kinds of stuff in there.
Wedges, putters.
Yeah.
I mean, iron, everything really. There's lots of models in the world these days. When we think years ago when I started this business, there was like 2 or 3 models of irons. That was it.
Right.
Now there's a ton.
Yep.
And there's more consumer need for all those because you guys are testing and fitting, and players are specific. I think it's where we see tour players. They're the most specific.
Right.
So that's why we started making them all these options to supply.
So most all your tour players playing printing irons now, or when does that happen?
They've played some form of 3D printed club.
Right.
Yeah, I think almost every one of them at this point.
Got an interesting story about Ricky.
Yeah.
So he's playing the King Tours, right? He
Right.
switched out of the MBs into the King Tours and ended up having a great year, right?
Yep.
Early on in that year, our Ben Showman, our tour manager, comes to me and says, I want to get Ricky a set with more offset because they bend all his irons like between 2 and 4 degrees, especially when it's been 4 degrees weak.
Right.
Right. So think about what that does to the offset, right?
Yep.
So we're like, yeah, let's 3D print them, right? And so we did, and we put offset in, and we got his head weights, which are heavier than normal, and some other specs, and his loft spec and lie spec. We printed all that in, made him look exactly like the King Tour, right? And we got the heads in right before
Except
the farmers
just bounce on it, probably, right?
didn't have enough because we forgot to adjust the sole because of the bend. So he plays them in the Pro-Am.
Right.
He's like, oh, these feel great, but they're digging a little bit. I think if we would have got the bounce right, they would have been straight and bent, right? And the only difference was it didn't say forged on the hosel. The caddy couldn't even tell them apart. Right?
Right.
And so we were just like, no, we screwed it up. And so we went back and we remade them with the correct bounce, and that took a little while to get him done. And by then he was just playing really great. Like the whole year he played great. So he's like,
can't change it.
And
I get that.
It's good back.
but that was another like proving ground of like, it wasn't because they were 3D printed he didn't put them in play. It was just the bounce thing. And like one that great players can feel that difference, right? And but it was like, this is coming.
Yeah, so,
this is
everyone
there,
understands
right?
the stuff. But basically, when you take an iron or a wedge or whatever, and you bend it stronger, not only are you changing the loft, but you're actually decreasing the bounce by the same amount of changing the loft.
In changing
So,
offset.
so you left the bounce alone and had an offset.
Yeah.
But you didn't decrease the bounce.
So it had like the production bounce on it, and which he was not used to that. So it was like as a win and a miss at the same time. I guess.
Great
Close
lesson
though.
learned.
Yeah.
Back to what's next. Okay, that's a little prelude to what can we do?
Right.
Yes.
That'd be an interesting thing too. I mean, bounce is pretty critical for players, especially better players, right? I mean, higher handicaps you just need bounce to just dig into the ground, but better players, the bounce I think makes a huge difference. And it's not just a bounce in your wedge, because that could be different, right? You can have a lower. I mean, I play a lower bounce 60, so I can hit a R band, a higher bounce 53 or something, But all through the set, the irons, and as you change them, make them stronger, you're decreasing them. All that stuff changes and matters.
The ability to decouple some of those specifications is huge.
Yeah, exactly.
Huge, right?
Be able to change the bounce without changing the lofts.
Yeah.
Or the ability to change the offset without changing the bounce, or whatever is really cool.
And that's the outside stuff. We go back.
So we're
to the
limited,
inside.
as fitters. we only get to play with what you send us, right? So we're limited, and we have to understand that those things happen.
But the future is coming where and we're doing it now for tour players to learn and develop and figure all these things out.
I mean, angle attack, your biggest variable on bounce for the most part.
Yeah.
I mean, we measure that stuff. I would see a point where we're really starting to play with that ourselves is, looking at their angle attack, trying to figure out what bounce works best. And as Tom Mace is working for us now, so we're measuring everything under the planet on these irons, trying to help us figure out how to narrow it down, right? Because everybody talks about, you got 40,000 demo combinations or 50 or whatever. That sounds great, but the guy's only hit three clubs and really determine the difference before he wears out. So that's the biggest thing we fight against. So if we could kind of determine, what bounce we're looking for ahead of time and help us narrow down the 3 that we're going to give the guy, that's why we do all this research. That's why we're testing everything in robots, and we're testing MOI and now CG, which we're going to publish all this stuff, whether you guys like it or not. But
We like it.
We,
you guys
we
do,
like it.
I think. to
Oh
some
yeah,
extent,
we
because-
like it. Yeah.
Yeah,
it cuts through the clutter.
Huge advantage.
yeah,
We've used the word excited several times in this conversation.
Right, right.
Everything you just said. So imagine the world
right.
we can bring to golfers.
Yeah, that's what excites me, right?
Yeah.
I mean, to be able to say, yeah, I want to set 4-through pitch, and I want a little more offset and more bounce to this guy, and be able to order him that way. I mean, that's a little off in the future somewhere, but I mean, that's pretty cool.
Yep.
Yeah, it's come a long way since what colored dot you want to put on it. Right?
I know.
So
Yeah.
start changing everything else.
And part of that, Mark, as you know, is the diagnostics, the AI part of that,
right,
knowledge, specs, fitting. So we're spending a lot of time on that too, because we could change all these things. So that's where the deep research is.
Right.
And we're spending a lot of time on that because we know we got to find the solutions. So
right,
we're going to keep talking a lot here in the future.
yeah. I think that's pretty cool.
Yeah,
Yeah.
We're excited to hear the feedback once people get them in their hands that other than you,
Yeah.
the consumer. So
Well, I haven't actually, we haven't shipped them to anybody yet, so I don't know how I like them. I mean,
They're coming.
I've hit the 7-iron a bunch,
yeah,
but that's about it. So.
And Tom's right? Getting feedback from you and the consumers that are playing these in any of our clubs, right, is huge for us. We're always looking for, okay, how can we make it better? I mean, the very first question we ask people when they come in is like, don't tell us what's great, tell us what's not working.
Right.
And that's what we want to know. Yeah, from you and your consumers, like, what's not working? What can we do better?
Yeah. Think about software updates. It gets pushed out to your phone. Like one idea that I'm excited about, but I don't know if we'll do it. But like there's no tooling, so it's like you could continuously improve this thing. Doesn't mean you can't go make something. It's all digital files. You can't just go. You can go make something you made 2 years ago or 1 year ago or whatever. But you can also continuously evolve it and say, okay, at this moment in time, you're getting version 1.1, right? And 2-3 months from now, if you're buying it, you're getting 1.3 because we made it better, right? But if you really want 1.1, okay, you can probably make that for you. Yeah, or if you have them, we have a file for what you have, so if you need to go make another one,
Yeah, that brings up a little conversation, and let me just touch base a little bit on this. I mean, everyone talks about AI, right? And that's kind of the buzzword for everything right now. And we're looking into it. I mean, obviously, we're not a technology company like you guys are to some extent. We're kind of trying to do what we can with the clubs you send us. But AI is really interesting on things you can find out. And one of the things we're doing is we actually now categorize every customer we got comes in. We know what his handicap is, and we know his club head speed, and we're starting to gather all the launch monitor data. And even now, we're looking at like Sportsbox, gathering 3D data on everybody. And over time, the big thing is AI that I think people don't realize is AI is great if you have really good data.
Yes.
And that's what I'm working with worldwide and stuff is, we want to collect as much data as we can so that we can understand, where we need to go with some of this stuff. And I think, longer term, I think that's what's going to influence bidding, right?
Sure.
As we learn over, what types of swings and does the guy does this, does that mean he needs a higher launching shaft or whatever? And I think if we have really good data over time, AI, that's what it'll find. Right? So
you're right. So we used a lot of the subset of AI and the machine learning part, right? So AI is the big all-encompassing, especially marketing people love to say AI.
Yeah, exactly.
But
I think that's overused, by the way.
Machine learning is what's we're really using and what other companies are probably really using.
Right.
And you just hit on all of it, like the robot data. So Bryce Hobbs, who was in innovation, who's now in design, and someday we're going to get him back into innovation, by the way. He did a really good regression model of robot data and the based on delivery characteristics, and then especially the mass properties of the iron, using robot data and hit locations. Like, okay, if you want to influence speed or spin or launch angle, what are the critical things to do to influence those, right? So we're going down the same path you are, right?
Yeah.
You're looking at it from a player standpoint. We are too.
I'm trying to match the clubs to,
Yeah, and we're trying to match the head,
right,
to that delivery.
You're just looking at, you're doing the same thing in different directions, right?
Exactly. Yeah. So it's all coming. Yeah.
Yep.
It's very useful tools. Yeah.
Yeah, I think that's the whole difficulty, I think, and there's a bunch of different levels of fitting, right? I mean, there's what we do, which is 4.5 hours, and costs some money and takes time, and to the basic fitting, you go in and hit a couple clubs and see which one works best. But the problem with fitting is it's all based on I hand you a bunch of clubs, which one do you like?
It's trial and error.
It's trial and error. It really has not progressed at all. Other than that, other than the fact that now we got 40,000 demos instead of 10, which is making it more difficult. So yeah, well, that's everybody, right? But longer term, we need to kind of help. The biggest thing in fitting, in my opinion, is to be able to narrow down which ones are the right ones. And honestly, once you do that, all three are the right answers. Some of that's just personal preference, right? I don't like the look of that, high toe or whatever.
Yeah, sure.
But there's no wrong answer. I mean, I think most every fitting ends up with a tie. There's two clubs we can't.
Close,
Yeah. I mean, and people's swings aren't repetitive enough. To determine which one's right. So there really is no right answer. It's just whatever one you like the look of the feel, whether you like the marketing and you like the guy that's on this staff or whatever, or you don't like yarn shafts or whatever, right?
Yeah.
So, but how we narrow it down to begin with, I think is the really key for us, especially in cool clubs, but even worldwide in a bigger version. We want to be able to basically narrow it down before they even start doing the fitting, and that's kind of what we're looking at trying to get. And that's just gathering a bunch of data and seeing how it worked over time and looking at sales and what ended up with people. And if you have good data, you can kind of narrow that down. That's kind of what we're trying to do.
Yep.
I mean, I definitely envision at some point in time, especially for high handicaps, we can literally video their swing, capture all their information and stuff, and do a pretty good job recommending.
Right.
And I would argue at a high handicap level, that's probably better than you going into a bay and trying to see if this one's better or the other. I kind of told the story, I think it's kind of funny, but so if you go to a bay and you sky the 9 degree and you top the 10 degree, which is the right loft? I mean, how do you pick? Right? So that's, you got a high handicap in a bay. That's kind of what you're doing. You're almost better off saying what's your angle of attack and then kind of giving you the clubs that work best for those parameters. Obviously, as you get into tour players and stuff and they want to see it through windows and stuff, the advanced fitting that we do is really important for better players. Yeah. But I think it's almost a disservice sometimes to.
It's actually easier to fit a better player than not a.
Oh yeah, it's really hard. If you're doing trial and error and you don't know which one to compare, it's difficult.
Yeah.
And so I think it's going to kind of verge two ways. We'll be just looking at their swing characteristics and kind of matching them up with clubs, which is probably better. And then you get better players to feel and the window you're looking for. That's fine tuning stuff, right? But you need the ability to be able to do that. And it just changes. There's more and more products on the market. Started years ago, we had 7 or 8 different irons, and now we have 50 of them. So it's an ongoing process.
But I would say that any consumers who are listening to this right now, as much as that seems daunting, it's worth it.
Oh
Go get fit.
Oh, there's no question about that.
Oh my gosh.
Yeah.
It
No matter what level you're at and stuff.
I don't care.
You can certainly narrow it down. Yeah.
Yes. Yeah. If you're a beginner, if you've got the wrong club in your hands, you could ruin your game.
Absolutely.
You could hit golf.
Yeah.
Yes.
Yeah.
And then if you're a very accomplished golfer, right, you can help them be more accomplished.
Oh, absolutely. It makes a huge difference. And most of the companies all have pretty good products at this point. Just matching up what it's designed to do and that player, really.
Well, hey, thanks for coming down.
I really appreciate you guys here, and if you show me anything I'm not supposed to see, let me know. And
we'll turn the camera off.
Okay. Cool.
Shortly after this.
I'd love to hear a little more about it. That'd be great. Appreciate it. Thanks for having me.
Thank you.
Guys.